An object is an instance of a class. You might define the class, or it might be defined in a library, like the string class that we've been using from the standard library. You define your own classes with the class keyword, and if you know how to do it in some other languages like Java or C#, you may believe you know how to do it in C++. You'll be mostly right. The first thing that trips up a lot of people with experience in other languages is there's a trailing semicolon. So it's class, and the name of the class, an open brace bracket, all of the definition of the class, close brace bracket, and then a semicolon after that last close bracket. A lot of people forget that one. And I mention it because it can cause some really weird error messages that happen on the line after where you define the class. As well, the inside of the class, you don't go line by line, this element is public, this element is private, this element is private, private, private. Instead, you have sort of a section. You say from here down it's public, and then you hit the private keyword, and from here down it's private. And if you don't say anything, the default is that it's private. C++ won't stop you from declaring public member variables, but you shouldn't. You should have private member variables and a mix of public and private functions depending on your design, your architecture, what they're used for. So functions that you're offering to other classes to use will be public, and those that are kind of your own convenience functions will generally be private. I've mentioned before that one of the hallmarks of C++ is that your classes and classes from libraries you're using really have the same rights, responsibilities, and abilities as the fundamental types. So you declare instances of employees or insurance policy or whatever your business objects are, just the same way that you declare instances of integers or any of the other fundamental types that we went through in the fundamental types module. When you want to use that object, chances are what you want to do is call some member function of the object, or possibly if you made a public variable, access a member variable of the object, and you would do that using a dot syntax. You've seen the scope resolution operator before, the double colons between the namespace std and the class name string, for example. It also is used for static member variables and static member functions, class name, colon, colon, and then the element that you want to access. We're going to start simpler than that though, because before you can start to access member variables and functions of objects, we need to be clear about how to define a class, and that's where we need to start. So let's write a class and then use it. Come over to Visual C++ Express, and I'll use this new project link on the start page to make a new console application as usual. And I'll put the project in my projects directory here. And call it classes and objects. We go through the wizard as always and just check here, yep, console application, precompiled headers, nothing else is set, hit finish. You can see that the new project template generates a main, which we'll come back to, but what I want to start with is our class. In theory, I could simply start to type the definition of the class right here in this file. It's possible for your C++ application to be one giant file. I'm going to create separate files, and the project system will pull them together when we build. So I'll start by right-clicking the project and saying add a new item, and I'll add a C++ file. I'm going to call my class person. So I'd like a file called person.cpp. There's absolutely nothing in the file. It's simply an empty file that I can do whatever I like. I could type the definition of the class in here. I'm actually going to add this sort of magic invocation line that you'll see anytime a project made with Visual C++ Express or any other version of Visual Studio uses the precompiled headers, the very first line of your file needs to be this include of the standard headers, std.afx.h. If it's even second, you get error messages. So I like to put that in right away so that I don't forget. Now the next thing I could do is to actually type the definition of my class. So I'm going to make a class called person, open brace. Here's where the definition of the class belongs, then I'll have a close brace, and then I'll have that trailing semicolon that I mentioned. And in here, all the definition of person. However, I obviously intend to use this person class more than just here in person.cpp. I intend probably to use it over here and create some instances and so on from inside this main. In order to do that, main would have to know that person was a class. And that's where the header file comes in. So I'm going to add another file into my project, a header file, which I will call person. And I'm going to take this definition of the person class, cut it out of here, and paste it into here. Now I can define person in the person.h header file and include that header file both here in person.cpp and here in classes and objects.cpp so that I can use person objects. Now what am I going to put in my definition of a person? Well, we all have names, first name, last name, so those seem like good candidates, and they are probably best represented as strings, so I'm going to add an include statement to let me use string from the standard library. So then here inside my definition of my class, I'm going to put these three member variables. By default, everything is private unless I say that it's in the public section, but just as a matter of politeness for people who read your code, it's a good idea to specify things. So I'm going to say private. You notice it turns blue, it's a keyword, and the colon's important. And now everything that I list after this is going to be private until we bump into the word public. So I'm going to make a string for the person's first name, and another string for the person's last name. And then just so that we have something in this class that's not a string, I'm going to add an integer, and I'm going to call it arbitrary number. Depending on your business problem that you're solving, this might be somebody's salary, it might be somebody's age, it might be somebody's number of dependents, it could be anything. It's just a number just so that we don't all have strings inside person here. So this header file, person.h, is now doing a pretty good job of declaring the person class. Let's go into person.cpp and we'll add this include for person.h, and I love this IntelliSense to help me remember the names of headers. Person.h is exactly what I want. And then we'll come here into the main and include person.h in here also. Once we've done that, this piece of code now knows what a person is, so I can write lines like this: person P1, person P2. The same as declaring an integer or anything else, the type and then the name that you want to call it. And presto, I have some objects. Now these two objects, P1 and P2, are both of type person, but just as if I had two integers, I and j, their values are entirely independent, and so it is with these people. This code allocates a person's worth of memory for P1 and a person's worth of memory for P2, and it's there, ready to have values in it and ready to be used. The values for most types in C++ are not defaulted or initialized for you. It's possible for objects to have them defaulted and initialized. It's not possible for integers. So if I just say integer I, it doesn't have a value. It just has sort of random stuff that happened to be in the memory. when we created a string in earlier demos, it was initialized to quote to an empty string. That's done because it's a class. The person who wrote the class decided if you just say that you have a string, it should be an empty string. And we have the ability, which you'll see shortly, to do that for person, but I haven't yet done that for person. So person P1 will have memory for a string for first name, memory for a string for last name, and because they're strings, they'll be initialized to quote. And it'll have memory for the integer, for arbitrary number, and that won't be initialized, so it'll just be whatever number happens to be in that piece of memory. And the same will be true for P2. I'm going to show you in the debugger how this looks so that you can see what's happening with those variables. So I'll set a breakpoint on the initialization of the first person and run. We'll have to build it first. I had unsaved changes when I hit run. That's fine. Saves my changes. It's going to build for me. And when we reach this breakpoint, before we've executed this line, P1 is full of things that are showing in the debugger here in the watch window as being bad pointer. Don't worry about that. Once we go over that line, you'll see that first name has been initialized to quote, last name to quote, an arbitrary number. It's just some random stuff that happened to be in that memory location. P2 is still uninitialized. We step over this line. His first name and last name have also been initialized to quote, and the arbitrary number, again, it looks like the exact same number. That's because this is a debug build, and in order to help developers spot uninitialized variables being used in debug builds, the memory is sort of pre-populated with signal values. However, P1 and P2 are completely independent, each with their own copies of these three variables, and I'll show you that very shortly. Let's stop the debugger, because obviously in order to demonstrate that these are independent, we need to be able to get values into the variables. To put something in P1's first name, put something in P2's first name, and see that they are different and that changing one didn't change the other. There are a couple of ways to do this, but since we were talking about initializing, this is the time to talk about the constructor. A constructor for a class has the same name as a class, and it's used to initialize instances of that class or objects. So I'm going to add a constructor to person. We'll go into the header file where we've declared the class, and I'll add a public section, because obviously this constructor isn't much good if people can't call it. And the name has to be person, and it doesn't have a type before it the way some other things might, because constructors, they just don't. I have to specify what kinds of values can be passed into the constructor to initialize a person. We could choose no values at all. When we make a person, their first name is quote, their last name is quote, and their arbitrary number is 0, or -1, or 107, or whatever you'd like it to be. But a more useful constructor takes values and puts them into the member variables. So that's what I'm going to code here. I'm going to say that I take a string from the standard library called first, and a string from the standard library called last, and an integer called arbitrary. And that's what this function is defined to be. And I put a semicolon here. In the header file, I'm only saying that this function exists. Remember that other files include this header. They only need to know that the function exists. They don't need to know the code for it. So we'll go over here to put the code for it. To code the constructor, to code anything inside the CPP file, I have to give the full name, which includes the class name. When we're here in person.h and I'm typing in what person takes, you can see I'm inside class person. I'm between the open brace and the closed brace of person. Here I'm not. I'm just kicking around in space. And so when I want to code that person function, I have to say before that, person : This is the class name, and this is the function name. The function name for a constructor is always the same as the class name. It's possible, although it would be horrible practice, to have in this file the implementations of a bunch of different constructors from a bunch of completely unrelated classes, and the compiler could work it out. it wouldn't be a good thing to do because humans who are going to read your code couldn't work it out, but the compiler doesn't demand one file is for one class, and as a result you have to specify. Here's what I'm doing. I'm implementing the constructor for person. Now I've read Wrigley's right now because the constructor for person takes those three parameters, the first name, the last name, and the arbitrary number, and I haven't typed that part yet. So I'm actually just going to copy that part. And I'm using Control-Tab to flip between the files. I'm just going to put this up onto a single line to make the rest of it a little more readable. And to define the body of the function, I need an open brace and a close brace. And in between is the body of the constructor. Now, here's how a lot of people would like to write this constructor. They say, sure, you've got a member variable called first name. I remember that. So we'll use that, put first into that. And another member variable called last name. We'll put last into that. And you got a member variable called arbitrary number. And we'll put arbitrary into that. This isn't exactly wrong. I can build this. And although I get an error, it's not an error in person.cpp. You can see here person.cpp generates code, compiles, then it moves on to the next file. I will discuss this error later, but here this code is fine from the compiler's point of view. It is, however, not the correct code to write. And this is something that people who are comfortable in other languages come over to C++, they write code like this all the time, and then experience C++ people tell them that they're wrong. And they say, how can I possibly be wrong? It compiles, it runs, it puts values in my variables. I don't know what you're talking about. And it has to do with this idea of how you default or initialize the member variables of the object. When you code it this way, what ends up happening behind the scenes when you create P1 is that first, all of the member variables are given their memory, and if they have default values, they're defaulted. And then when we hit this open brace bracket, all of the member variables exist, they have memory, and they've even been initialized if they can be initialized. And then their values are changed. If setting the value into a string were terribly expensive, which it isn't, this would be a real waste of time. First setting it up to its default value, then changing to the value you really wanted. Obviously, for something like an integer, where there is no default value, this is harmless. And for strings, frankly, it's not a very big deal, but it's a bad habit to get into. There are also some times when it's actually not possible to write this code, especially later when you get into inheritance, you'll see that. So you want to do things right from the beginning. And in C++, right means using something called initializer syntax. When your initializers are expensive, initializer syntax is one of the ways you make your application perform better. One of the ways that C++ gets really obsessive about performance is saying don't waste your time initializing to a default value and then immediately changing the value. Just initialize it in the first place using the value you intend to use. And that's done with initializer syntax to pass along the parameters that came in the constructor. C++ certainly likes to be terse sometimes, and the syntax for initializers is a single character. We just type this colon, and then we rattle them off with the member variable name and what we want to initialize it to. So we say I want to initialize first name to first, and then comma, I'm going to initialize last name to last, comma, and I can have line breaks if I want them, just helps to make things readable. And I want to initialize arbitrary number to arbitrary. Once I've done that, I don't need the body anymore. And this is a very common pattern to see in a constructor, that the open brace and the closed brace have really nothing in between them. So the role that the constructor is serving here is to sort of be a traffic cop and direct those three parameters off to these initializers of my three member variables. The benefit here is that if it costs to initialize that first name, we're only going to initialize it once using the parameter that was passed in. rather than once to a default value and then assigning it the value that was passed in. So if I can build this again, you can see that person compiled without an error. There's no output related to person. But again, we're getting these errors in classes and objects. And now I want to show you what those are. So we'll go over and look here. It says person, no appropriate default constructor available. So a constructor is this function with the same name as the name of the class. And a default constructor is a constructor that doesn't take any arguments. And this is a fair complaint. If we look at all of the constructors for person, there's only one and it takes 3 arguments. There isn't one that doesn't take any arguments. But some of us may be saying, I don't understand because before this was okay. Before when we said P1, we didn't pass in any arguments and the compiler had no complaint then. When you don't write any constructors, you get a default constructor for free. It doesn't do anything, but it exists and it keeps the compiler happy. You can't see it. It's not generated for you by some sort of wizard. It's actually written by the compiler every time you compile your program. The minute you have one constructor, the compiler is in effect saying, I see, you know what you're doing. Right, fine. If you wanted a default constructor, I guess you would have written a default constructor. And so it doesn't make one for you anymore. And that makes this code say, well, what I need here is a constructor that doesn't take any arguments since I don't have any arguments. And then it can't find one, and then you get this error. You can see if I hover here, no default constructor exists for class person. I could write a default constructor for class person, that'd be trivial. But the only reason we wrote this constructor that takes the 3 arguments was so we could call it. So I need to change this code to call that constructor. So the syntax for initializing objects using a constructor that takes arguments is with round brackets. You may remember from the other demo, you can say int I, and then on a later line you can say I equals 2, or you can say int I equals 2, or you can say int I round bracket 2, close round bracket. That also initializes. That round bracket syntax is the way that you pass one or more parameters to constructors of objects. So I can say here, quote, I'm going to make a person based on me, so I'll pass in Kate, comma, and my arbitrary number can be 1, 2, 3. And then we'll come down to this next line, and we'll do someone else. And their number can be 4, 5, 6. So now I'm constructing my 2 different person objects, P1 and P2, and I'm using that 3 argument constructor to get values into them. So let's run again. So if we step over this first line, you can see that P1 has those values. Drag this over a little so you can see all parts of it. And if I step over here, you can see that P2 has completely different values, and that changing P2 didn't change anything in P1. Hopefully that's not a very big surprise. So we'll stop debugging. And now I'm going to briefly have a bad practice so that I can show you something, then I'll make it right again. I'm going to make one of my member variables public. You really shouldn't do this, but it lets me easily write some code to set its value without having to get into the ways you really should be setting values. We'll do that shortly. So I'm making arbitrary number public. And then I can come in here and say, with the dot syntax, P1 dot arbitrary number is equal to 1, 2, 4. And we'll do for P2, also change the arbitrary number to 4, 5, 7. And we can run this. And just as we step through, you can see P1 being created with value 123 for arbitrary number, and now you see it change to 124. P2 being created, and arbitrary number changing to 457. This dot syntax, the object's name, dot field, or member variable, or member function, or whatever part of it you want to talk to, happens whenever you're dealing with So let's write a class